Welcome back to our particles project. In the last video, we made the particle metal, which metal is not all that exciting, right? All I can really do is click on the screen and it just kind of stays there. Now we're going to make the sand particle, and I think sand is a lot more exciting because how does sand behave? Sand actually falls down. So this is going to be our first kind of fun motion heavy particle. Let's go through that whole process that we talked about last time for how I make a new particle. The very first thing is I need to add a constant for that particle. So up here at the top, let's write public static final int sand equals 2. The second part of that process is sand needs to have a button on the screen, so I can choose to put sand on the screen. To do that, in this array here, I'm going to say names bracket sand equals sand. Now, I did just add an entry into this array that was too long before, so I do need to change this number, right? Because there's not 2 things in there anymore, now there's 3. If I scroll down a little more, in location clicked, I need to be able to click on the screen and put sand on the screen. So let's do if particle type equals sand. We're going to say grid row call equals new sand. Now, again, this is going to get a little bit annoyed at us because we don't have a class representing sand yet. So let's actually go ahead and make the sand class. To make the sand class, I'm going to go over here and remember what we did last time to make metal. I'm going to click like I'm going to run this, and then I'm going to duplicate it. And let's call this sand. There's 2 things I have to change in this class. The first is, remember, this constant has to align with the one that's in particles program. So I need to call this sand. And I probably want to change the color, otherwise, again, I won't be able to tell the difference between sand and metal. So let's make this color dot yellow. Great. Now that we have this, you should be able to compile it. Again, we haven't changed much here yet. And then let's go back to particles program. Let's actually run this. Let's make sure it works. So let's run particles program. And look, now I have a button for sand. I should be able to run and add metal and run and add sand. And now we haven't made it fall yet. So really now all we have is MS Paint with 2 colors. Woo, very exciting. If yours is having an error right now, probably one of 2 things happened. Either you forgot to change this number, which was a 2, to a 3. That's really important that you do that. Make sure you have a constant for sand. And then in the sand class, make sure this is particles program dot sand and you've changed the color. So right now we have sand, but sand doesn't actually do anything very exciting. And that's because sand, unlike metal and empty, actually has a behavior, which is sand needs to be able to fall. And how are we going to make that happen? Well, there's one method in here we haven't really touched, and that's this method called step. Essentially, the way that our particle simulator is going to work is instead of looping through the entire grid and saying, you do a move, you do a move, you do a move, you do a move, we're going to randomly choose a particle on the screen and make it do something. And what happens is that over and over again, I'm going to step different particles, and you're going to have this behavior where when a particle is stepped, if it has behavior that it should be doing, that behavior will happen. And the reason that we don't actually do it in a big RC Cola for loop to update everything is, 1, it's actually really slow to do that because my screen is pretty big. And 2, you actually get this interesting sort of randomness added in when what I'm stepping is a particle in a random order. It makes it a little bit more interesting. So to start, again, based on what this says, we're going to cause one random particle to maybe do something if it's supposed to do something. And this is called over and over again. So the very first thing we need to do is actually find that one random particle. Now, to get a random particle, I need to start with a random location on my screen, which means I need a random row and I need a random column. So let's do this. I'm going to say int row equals, and again, I've been saying random about 1 billion times. We're going to use math.random for this. So I'm going to do int math.random. And if I want this to be a random row, this really should be a random number that goes between 0 and the number of rows, not actually including the number of rows. So I'm going to do times, how do I get the number of rows? Is its grid.length. And then let's do the same thing for the column. I'm going to say int col equals int math.random times the number of columns, which is going to be grid 0.length. And this row and column gives me a location in the 2D array, which means now I can grab one particle from that. So I can say particle equals grid row col. Now, when I step a particle, I want to make it do something. And that depends on what the thing is that I step. So let's start with the easy ones. Let's start with if particle.getType equals metal. If I've stepped metal, do I actually want to do anything with it? I actually don't, so I'm just going to do return. And isn't that actually the same if I step the empty particle? So I'm going to add an or particle.getType equals empty. We're actually just going to do nothing, right? Because if it's metal or it's empty, it just sits there. But else if particle.getType equals sand, what does sand do is sand falls down. So I'm going to do this, try to fall down. Now notice I actually called this try to fall down, and that's because sand won't always be able to fall. If you remember from looking at the completed version of this, when sand falls, there's two places where it sits. If sand falls on top of metal, it actually sits on top of it. That kind of makes sense. Metal should be able to hold up sand. And if sand falls all the way to the bottom of the screen, it actually just rests right on the bottom there. So we're going to try to fall down, and in the cases where sand actually shouldn't fall, we're going to have it kind of sit there and do nothing. So try to fall down, this method that we're about to write, is going to take in as parameters the row and the column location of where we're looking. So let's write this method. I'm going to write public void try to fall down, which takes in an int row and an int col. All right, let's deal with when can sand fall down. Well, that first thing I said, what if sand is on top of metal? I can't fall down if I am on top of metal. So when does sand get to fall down is actually when the thing beneath it is empty. So let's check that. Let's say if, how do I get actually the row column location that's right beneath the one that I'm at? If I'm going straight down, doesn't the row actually increase by 1 and the column stays the same? So I'm going to do this. Grid row plus 1 col dot get type equals empty. Then that hypothetically means that's a spot that sand can fall into. And to make sand fall, essentially what I want to do is if I have a sand particle right here, shouldn't that sand particle kind of swap with the one beneath it? So let's do this. Remember, it takes actually 3 lines of code to swap 2 values. And that's because I don't want to overwrite one of the others and lose that information. So I'm going to do this. Particle save equals grid row col. We're going to say grid row col equals grid row plus 1 col. And grid row plus 1 col equals save. So I've kind of done this little swapping. This sand particle would swap with the one beneath it, and that would actually make it fall down 1 particle on the screen. Now, there's one other thing that we haven't handled here, which is what actually happens when you hit the bottom of the screen. Well, we have a little bit of an issue because which row actually doesn't have one after it? If I'm in the last row, the sand there shouldn't actually be allowed to fall because I can't access the row underneath it. So I kind of have to protect myself from potentially indexing out of the bounds of this 2D array. So what do I want to make sure? I want to make sure that the current row is not actually the last row. So I'm going to do row bang equals, and what is the last row? It's grid dot length, the number of rows, minus 1. Now the order of these two things is really, really important. If you flip-flop these, if you checked this first, that's actually a problem because you might be indexing into the row beneath you, but you didn't check to make sure you're not in the last row before you do that. So that might give you an index out of bounds error. You always want to check, do your kind of protection for yourself before indexing into the 2D array. All right, let's close out of, if you still have this running, close out of it. We can compile this. And let's run our particles program. And if we run our particles program, and now I drop sand, woo, that's kind of cool. And again, if I drop metal, let's put some metal down, the sand should actually sit on top of it. It doesn't fall through it. Kind of fun. In the next video, we're going to see how to code a different particle, which is going to be the particle water. Water behaves similarly to sand, except it kind of sprays in an outwards way. So it doesn't just fall straight down. So I'll see you in the next video where we're going to make water.